All right, guys, welcome to class. It is freezing in my classroom, so please ignore the beanie, but I don't feel like becoming a popsicle today. So, we are going to be covering balancing reactions today. Balancing reactions. So, one really important thing to note at this point in time, this is like a milestone in chemistry when you get to this point. And balancing reactions is something you are going to do with literally almost every problem in chemistry from here on out. Okay. It is one of those concepts that it's not one of those like, okay, if I really don't get intensive versus extensive, it's not going to affect me much. Like this is like, it will affect you every day. It's like not knowing how to read a periodic table or know what an atom is. Like it is fundamental, monumental, must know, like end of story, period, slap a cover on it, make it a book. I don't know what to tell you, publish that. You have to know how to do this. Absolutely must know how to do this. When I do my AP and IB classes, I like when I AP in the past, IB now, the first thing I did with them was a balancing reactions and stoichiometry boot camp. Like that's the first thing we did. Every single thing you do has to do with this concept. So today is important. If you didn't get that, today is important. So here's what I've done. We're going to do a quick warm up, and then I'm going to give you the opportunity to earn your way out of class. If you understand how to do this, and you show that to me and demonstrate that to me with the task that I'm giving you, you will be allowed to leave. If you cannot do that, okay, and you cannot do the task, I ask you to stay, because again, if you do not know how to do this one thing, the rest of your chemistry life is going to be real bad. Not even going to sugarcoat it for you, like real bad. When we get back from break, we're going to be doing the dimensional analysis stoichiometry thing where there's multiple atoms of things in there, like I told you was coming. And if you can't balance the reaction, you can't even start that problem, if that makes sense. So the first thing I do the first thing you do every time you see a chemical reaction is make sure it's balanced every time, like literally. So let's figure that out. So step one, we have to know how to count stuff. And step two, we need to know how to balance stuff. So we're going to count the thing and then we're going to balance the thing. And that's how today going to go. So let's talk about counting first, not Sesame Street style. Sorry, I was reading something. Let's start with, wait, where'd my name wheel go? Where did it go? Dun, 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 dun. Gus, how do you count the number of atoms in number one? How many nitrogen atoms are there?
There's one nitrogen thing because
How did you know?
you can see there's only one and there's no like subscript or whatever.
Yeah, there's no subscript, and if it's written, it has to be present. Like a lot of times students will say 0 because there's no subscript, but the fact that it's written means it's present. There has to be a with them, right? Perfect. Love that. For posterity's sake and just for fun, how many hydrogens are there? Hydrogens are there? I can speak words.
3.
Awesome. Thank you so much, Gus.
You're welcome.
It gets cold, my whole body stops working, like my mouth, my nose, like, oh, it's awful. I hate it. This is why I moved away from Michigan. I don't like the cold. I don't like it. All right. So, number 2, in that whole term, how many nitrogens are there? Esty, how many nitrogens are in this guy right here?
There are 4 nitrogens.
Good. How did you get there?
Well, I knew that there was a 4 in front, which means that there's both 4 nitrogens and 4 oxygens. And I don't know, off topic, but the O has a 2, which means it's 4 times 2, which would make the oxygen number 8.
That's perfect. See, not off topic. That's exactly on topic. That's perfect. Okay. All right. Next up, number 3, dun, 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 dun. Milan, do number 3. How many nitrogens are there?
I think there's 5.
You think there's 5? How did you get there?
Because the subscript's 5 outside the parentheses, so I think you would distribute that, and then it'd be nitrogen 5.
Yep. How many hydrogens would there be?
15.
15. Perfect. Now, fun side fact. Does anyone know what molecule that is? Is there any like super biology brains in the house? That like AP bio people or whatever? No, that's Rubisco for photosynthesis, by the way. So that's what that looks like. All right. And then this last one, number 4, Audrey.
6.
So for nitrogens, yep, there are 6. How did you get there?
Oh, am I looking for nitrogen?
Yep.
Oh no, yeah. Because there's a subscript of 2 and then there's a 3 in the front.
Yep, so that gives me 2N, and then there's 3 of them. So times 3, so that gives me 6 N's. Perfect. All right, so now we know how to count the thing. I need to know you know how to balance the thing. So I've had a couple people hit me up in the chat that says they learned how to do this before. There's like 5 of you that have told me that. That's lovely. Give me 5 minutes just to make sure for my sake, because a lot of times we think we know something and sometimes we get hit with problems that we don't know and we realize we don't know it as well as we thought. So give me like 5 minutes to have you prove that to me and then I'll let you go early, I promise, okay? For those 5 people that hit me up privately in the chat, okay? All right, so now step 2, we're gonna do the balancing reactions game. I'm gonna show you how the game works and what I want you to do, and then you're gonna get to earn your way out. Here it is. Bum, ba-da-bum. There we go. Can y'all see that? All right. So we're going to look at how this thing works first. I'm going to turn on a couple tools. So for those of you that are visual learners, you'll have nice visuals to show you. This is going to count how many of each atom are present. This is going to show it in a picture, and this is what we're doing to our equation. So on your paper, this is what would be written. So if I gave you this problem, Corey, what do you think is the first thing you need to do?
Hold on 1 second. You need to figure out how many of each atom there is on each side.
So that's the whole problem. What I would say for step 1 right now, there's nothing in my reaction. Why is there nothing in my reaction?
Because there's zeros next to each atom.
Right. So the first thing I would say is to make sure you have one of everything so you can see the ratios of everything. Now, if you're really good at math and you can do this in your head, you may be able to do that from this equation, but the whole point of this tool is to give you extra visuals while you learn to understand. Eventually, you will not have any tools. And as in eventually you won't have them when you do QC 6.2 tonight. But for right now, you will have them, if that makes sense. Okay, so here's that. Now what would you do, Corey?
You have to balance them and make sure that they like.
Man, you keep using
Go
this
the
word
same.
balance. What does that mean? That sounds like such a fun word. What does that mean?
You just make sure that there's like the same amount of like the atom on each side. So if there's 2
Perfect.
nitrogens on the left, there's
Science
2 on the right.
I love that. I heard you hesitate and use the science word, and I love that. So yes, the same number of each type of atom on each side. Remember that whole law of conservation of mass thing? We're doing electrons. I said you can't like Thanos something out of existence and be like, oh yeah, this doesn't exist anymore, right? Because right now I had 2 nitrogens and now I have 1 nitrogen. So did Thanos just like, boom, half the nitrogen's gone? Absolutely not, right? We have to have everything present on the left that was also present on the right, okay? So thank you, Corey. I picked on you a lot. I'm going to pick on someone else now. Bum, bum, bum. Ray, how would you start balancing this equation? Which one would you start with?
Like the side of the equation?
How would you start? Just tackle the problem.
I'd probably just throw some nitrogens in and then try to balance them out.
What do you mean? Throw some nitrogens in where? Can you be a little more specific? So I don't want
The product side.
the product side, and use the science word. Oh, gold stars, right? The product side, the right side. You would add a nitrogen. Why do you want to add a nitrogen to that side?
And then you can like get like a least common denominator and just like, I mean like a multiple and then like balance the other side out.
Okay, so for right now, we added a nitrogen to this side. I'm gonna mind read you a little bit here. We added the nitrogen to this side because there were 2 nitrogens here. Can we take any of these nitrogens away? Can we ever take anything away? make it disappear? Anybody? You think so? No.
No.
We can't separate those N2s and only use one of them. Have no fear of ice cold beer once you're 21 or your parents say so. And so N is one of those that has to appear in pairs. Okay, so we can't take one away. So the only thing we can do is add to the other side. And we can't add just the nitrogen. You can't make it N2H3 because then you're changing its whole identity, right? We're just making duplicates. So basically you're hopping in and cloning yourself. Okay, you can't just pop an arm off and make an extra arm. You're not going to end up with like 3 arms, right? You have to make a whole duplicate of each thing and you get an extra copy of everything. So that's what makes this difficult, okay? So we have the 2 N's, the 2 N's, and then for the H's, I'm going to start picking someone else, Ray. Thank you very much for your help. Eva, what would I do next?
You would need to add 2 more H's to the whatever side.
Yeah,
Yeah,
the
yeah,
right
that
side,
one.
the left side. Yeah. So we have 3 times 2 is 6. That's 2, 4, 6. And then we have 2, 4, 6 here as well. So that's each. And notice you get this pretty little smiley face. Yay, it's so pretty. All right. We're going to separate some water. All right, Sangeet, start me off. What do I do first?
Add 1 to all of them.
Perfect. Now where's my problem spot?
You have 1 less oxygen on the reactants side.
Oh, the science words. I love them. Makes me so happy. So yes, we have 1 less oxygen on the reactant side. So what do I do now?
You can add 1 on the reactant side.
Perfect. Yes, we add 1 on the reactant side, but now my hydrogens went all out of whack, right?
Yes, now you add 1 more H2.
Yes, and now what happens? So we have 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 1, 2. As you're using this tool, you can take away things as much as necessary so you can test yourself, or you can keep things added in to help yourself visualize. That is up to you. All right, this last one is, so to be clear, combustion is like the ant that seems like she looks normal on the outside, but when she talks, she will cray cray. Like that's combustion. It's gonna look simple, but the bigger this hydrocarbon gets, like if you get up to ethane and butane and things like that, the weirder the balancing gets. So I'm gonna show you a combustion one, but know that combustion could get funky. So like just be careful with it. And I can show you why later if you stay after, okay? Let's see. All right, so who's it gonna pick? Dun, 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 dun. Trisha, how do I start?
You add both the things on the reactant side.
Yep, so we have 1 of each of the reactant side and we can have 1 product and we're gonna see how we land. So Celine, which one of these is not like the other? Like I know y'all are too old for Barney, but like they used to play that game a lot, right? I don't know if they do that in other shows, but it's like, which one of these is not like the other? So which molecule looks different than the other ones?
The 1CH4.
So CH4 has 2 types of atoms in it. Does anything else have 2 types of atoms in it?
CO2.
And H2O, right? Which one does not have 2 different types of atoms?
O2.
Right. So when we're playing the game, which one of these is not like the other? Every single one of these is a compound except for oxygen with an element. So here's my pro tip. Thank you very much, Celine. Here's my pro tip. When you're doing combustion, do the one that's alone last. Why do you think I say that? Bob, why do I say that?
That the ones that's alone is last, right?
Yes. Why would you do the one that's alone last?
Because. Oh no.
Okay.
I have no clue.
All right. So let me ask you this. If I get everything balanced, if say I balance hydrogen first, okay, and I do this, and then I balance oxygen. Whoop, this is not a good problem to do this with. When you do oxygen last, when something's by itself, it only affects itself, right? So this is the example of like assignments by yourself versus group projects, right? If you have a group project due tomorrow and you have one person not do it, it's a big deal. And that one thing affects everybody else, right? So if I have to change the number of CO2 later on, because I'm balancing carbon later, like say I balance carbon last, and for some reason there's more than one here, when I up this, it changes the number of oxygen for the whole thing. So I might end up going back and rebalancing that oxygen like 6,000 times, right? Especially with combustion. So the order I tell you guys is usually carbon, hydrogen, oxygen. If you balance them in that order, it's way easier and it comes out right every time. Okay. So why don't you do that for me? Is carbon balanced?
Yes.
Okay. Is hydrogen balanced?
No.
Okay. So what do I need to do?
Add 1 hydrogen to the product side.
Yeah. So if you're not adding 1 hydrogen, you're adding 1 what?
H2O, so 1 water molecule.
Yeah, we are adding a duplicate, which gave us 144, and we have 142. So what do I need to do last?
Add 1 oxygen from the products or reactant side.
Okay, yes. So now we have the same number of everything. So to not belabor the point, what we're going to do now is, and thank you very much, Bob. What we're going to do now is we're going to play the game. Notice how there's 3 levels. Okay. You're going to play through all 3 levels. Okay. I'm going to give you a 15-minute timer. You have to get at least 13 stars to earn your way out of class. Okay. 13 stars. If you get 13 stars before those 15 minutes are up or whatever, then you will get to earn your way out of class. Okay. If you do not, I need you to stay after so I can show you. Because again, you're going to have to do this literally every single day, pretty much, minus maybe 1. Like this is a thing you're going to do every time you see a chemical reaction. Okay. Even if you don't physically balance it yourself, you're going to check and make sure it's balanced. Like balancing is always the first thing, especially if you're thinking about doing AP or IB, like you need to like into your brain real hard. Okay. So I'm going to give you guys this link. You guys are going to be in breakout rooms. You are going to come back from the breakout room when you are done, and you're going to share your screen with me to show me your 13 stars. Okay. All right. So, Wheel Sonali, what are you doing when you go to the breakout room?
We're doing this balancing reactions activity, and then you have to try to get at least 13 stars before 15 minutes to get out of class.
Yes. If you get those 13 stars minimum, what do? How do you earn your way out of class? What do you got to do? You got to come back to.
Oh, you have to share your screen to prove that you did it.
Yep. And if you can show me 13 stars before 15 minutes, you are free to go. And you have QC 6.2 due tonight, which is a grade. So make sure you do it. A lot of you got blasted with a lot of emails about grades yesterday, and you're going to get more today. Suck it up, buttercups. It's coming. Okay. All right. There is the link. Go to the game, open the game. I'm going to put your breakout rooms together so you can help each other if necessary. All right. Rooms are open. Timer has started.
Are we allowed to pick our breakout rooms?
I can move you if you want. Sure. Where do you want to be?
It's fine. It's fine. I'll just stick
Yeah,
with.
since this one was timed, I was figuring just quicker as possible.
Mm-hmm.
Mm-hmm.